Up next are two back-to-back in-depth sessions that will discuss threadbare, various aspects of the disruptive technologies of AI and ML. IT leaders are looking at these technologies over others in reclaiming business growth. The experts who will showcase the value from AI and ML in the order of presentations include Dr. Ankur Narang, VP AI and Data Technology, Hype Messenger, and Ms. Vidhya Ji, Director Engineering at Uber.
Yeah, hi everyone. I'll present an AI workshop today as part of the ATCIO Spectrum Business Conclave. And I'll basically go over the history and advancements in AI, giving some idea of the key AI technologies that are enabling huge number of use cases and very impactful use cases across academia, business verticals, across many industries. Going into how can AI help in the pandemic recovery, what impact can it have on the recovery for the economy, for the industry, for so many healthcare problems that we are observing in the pandemic right now and the predicted kind of coming in the future, and what are the specific use cases that could actually materialize over here which can have huge impact in the recovery from the pandemic, and followed by conclusions. AI primarily right now correlates to deep learning, and it has a long history starting with neural networks in the 1943s, going into the perceptron, the backpropagation, RBMs, RNNs, CNNs, finally leading to deep learning as the term got coined with deep belief networks in 2006 with Hinton's work. And subsequent to that, there were interesting discoveries and innovations happening around 2009, ImageNet and AlexNet, 2014, generative adversarial networks, GANs, which showed a lot of potential in generating complex objects and complex distributions. Finally, going into innovations in reinforcement learning with AlphaGo, AlphaZero from DeepMind in 2016, 2017, and then the latest ones in the last 2-3 years around transformers that help us model the underlying distributions in natural languages and also now other areas, vision, and even biotech in very interesting ways. So a lot of the advantages and opportunities in AI have come around in the last 4-5 years. And these primarily have revolved around deep learning with transformers, especially now GPT-3, which got released last year by OpenAI, and it has shown huge performance improvements in very high quality natural language generation with lots of use cases coming in natural language applications. Furthermore, in terms of modeling of the languages in unsupervised techniques, these transformers have helped quite a bit over there and has really improved performance over the typical LSTMs, GRUs, RNNs, and so forth. Another area that has come and advanced MLAI technologies quite a bit is reinforcement learning, specifically deep reinforcement learning, where deep learning combined with reinforcement learning has helped to the AI to perform really well on strong games, many games over there, as I'll show in the slides later, which primarily use techniques around self-play and automatic domain randomization to ensure essentially that the computer plays really well and beats the best humans in the respective games. Another technology which I mentioned earlier is generative adversarial networks, where complex distributions can be generated by AI with sophisticated modeling techniques and underlying game theoretic aspects. And going so further, advancements of CNNs into capsule networks and so forth, a lot of interesting architectures are getting explored, which have huge potential to impact multiple verticals. These verticals, as we have seen, span from chatbots, Siri, Alexa, to recommendation engines from Netflix, and many more now coming in all the verticals. Self-driving cars, dynamic revenue optimization, finance, cybersecurity, deep applications in healthcare, which are booming, especially with the coming pandemic. Lots of applications coming further, not only at the biotech level, but at a generic healthcare level in various companies, and going all the way to complex problems like earthquake prediction, environmental conservation, oil and gas, and so forth. So there's a whole plethora of problems that have come across in various industries, and they are powered by these underlying MLAI technologies. So one of the key innovations that has come in 2017 from the paper by Vaswani et al., Attention is All You Need, which got published in NIPS 2017, essentially is around transformers, which is basically giving or having attention on the input and having multi-head attention, which essentially means looking at a language translation problem, converting essentially, let's say, a sentence from one language to another. What are the different perspectives as a human does to look at the underlying sentence, let's say in a particular language, and then using all those perspectives together to finally combine and generate a new kind of a sentence in the destination language. So here, the query key and values are being used to model these multi-head attentions, and with the appropriate encoders and decoders, the corresponding very high quality output of natural language translation or neural machine translation is happening now. This technique of multi-head attention is now getting used not only in natural language processing, natural language understanding, but it's also used in computer vision and many other areas in the context of AI. One particular aspect over here is BERT, which essentially is a paper that came across in 2018, which applies the aspect of transformers further into generating interesting encodings using deep bidirectional transformers, and this generates very interesting language models for which the downstream tasks attain very high quality. Here are some applications of BERT that have been tried out, and more coming with variations of BERTs. These include sentence classification, sentence pair classification, similarities, multiple choice, sequence tagging, sentence tagging, and question answering. Here are some of the transformer-based language models that have been developed, and they continue to evolve. These essentially revolve around BERT from Google, ExcelNet from CMU Google, Roberta, Facebook, DistilBERT, CTRL, GPT-2, followed by GPT-3, which has very unique creative abilities in generating natural languages, Albert from Google, and Megatron, which is one of the largest transformer models trained on a huge cluster of GPUs with very interesting set of results. Another set of area is reinforcement learning, where we saw in 4 or 5 years back, deep Q networks from DeepMind, they beat Atari in multiple games. And even in AlphaGo, DeepMind demonstrated huge gains in performance with AlphaGo performance, zero performance within 43 days with a self-play only kind of a training algorithm beat Lee Sedol, the master of the game of Go. This has led to further enhancements to the algorithms in deep reinforcement learning, where in Dota 2, essentially the game that involves teamwork, long time horizons, and hidden information is where, again, the OpenAI team over here now, beats the OG team, which is the 2018 World Champions in April 2019. This shows further progress of Algo OpenAI 5, which has won against the Dota 2 champions. Another problem that has been looked at is Quake 3 Arena Capture Flag from DeepMind. And here, essentially, there are multiple agents who would need to learn to act independently. They need to interact, cooperate with other agents, and essentially adapt with the agents in a constantly changing world. This essentially makes it a very hard problem. But again, here, what DeepMind has observed is that the agents automatically figure out the game rules, important concepts, behaviors, strategies, so that they can actually automatically learn to have home-based defense, opponent-based camping, teammate following, and other strategies and behaviors, which is a hallmark of the kind of level deep reinforcement learning has given in terms of the cognitive abilities to these bots. Another example is for the game of Starcraft, where AlphaStar from DeepMind, evolved from 2018 to 2019 and now has reached the Grandmaster level for beating the best humans at this game. So AI for pandemic recovery, has implications in multiple dimensions. In the economy, there are interesting cases where AI economist effort from Harvard and Salesforce is used to simulate and optimize various functions of the economy. Here, the idea essentially is to model the system as multiple agents, the whole economy as multiple agents, or parts of the economy as multiple agents, and basically perform analysis and simulation of kind of what if types, what are the various ways in which the economy can behave, what are the various changes can happen under certain assumptions of how the agents are behaving, whether they are fully rational, whether they are partially rational, and how essentially what kind of changes can be done so you simulate scenarios and you can get better kind of ways in which the recovery can happen for the economy under such a pandemic. It is used to model minimization of job losses. It can be used to model generation of dynamic schedules where particular locations can be targeted for lockdowns and at certain points of time, whereas at a later point of time, full economic activity can be enabled in those locations. So how is the kind of this orchestration, which is a very complex problem, given there are so many interdependencies in the economy, essentially becomes a large-scale computational problem with full leverage requiring from the AI perspective. One could also use this for company and industry performance prediction and prediction of impacts on the financial markets. As one see, this is a large problem, but with such effort, one could essentially look at subspaces in this large problem and try to improve particular aspects, and each aspect would lead to and contribute to recovery of the economy. Other aspects include face news detection and removal on social platforms, which could lead to transparent and truthful understanding of the actual facts, which kind of accompany this kind of pandemic recovery. And also putting in like autonomous police robots, which can be deployed for patrolling areas to confirm that lockdown orders are being followed, the corresponding social distancing and appropriate norms for the lockdown and quarantines are being followed. Another aspect that AI can help is from an industry perspective. Here, as we have seen, video conferencing and virtual plus augmented reality can help in improving the employee engagement, enabling brainstorming sessions, making sure that the office is going on from working where people are working from home, but it's going on in a perfectly smooth fashion. Another aspect here is virtual assistants, which can help in marketing, and in such a situation ensure that the corresponding lack of people not being able to meet each other does not impact the marketing activities, whether it's B2B, B2C, and so forth. Virtual conferences, aided with AI, actually are a big way in which it's enabling people to meet each other without being physically attending conferences. And this has helped the various features or the capabilities that AI has added to these virtual conferences ensures that people have close to, if not exact, kind of experiences as if they were meeting physically in those conferences. Another aspect includes computer vision and IoT-driven monitoring of staff, where the company can ensure that social distancing, mask wearing, and related functions that are there at workplace essentially, follow in a way that the pandemic gets controlled, and while the normal functions of the work continue in the normal way. Further customer behavior analysis, including changes in patterns, those can be analyzed, and the corresponding adjustments to business that needs to be done can be inferred in such a crisis. Further, predicting the financial performance of the company, visualizing in interesting ways can make sure that one is fully prepared for any downstream surprises that are coming, and how essentially to optimize the whole business operation so that under tight conditions, with limited cash flows, one is still able to ensure that and navigate through the pandemic. Another interesting aspect that AI can help here is healthcare, right? So here, what kind of outbreaks could happen subsequently? How do you minimize or stall the spread of virus is something that can be predicted, and appropriate actions can be taken using the capabilities of AI. Clinical trials for drugs and vaccines can be optimized using AI. In fact, there are tools to design drugs in a simulated environment, and then only the interesting candidates can be tried out. The same thing for vaccines. These kind of technologies which combine AI with supercomputing essentially help large companies to try out the drugs and the vaccines in a much more effective way before trying it on the real people. This would be very effective in reducing the total life cycle times of developing these drugs and vaccines and bring them earlier in the market, because it is pretty much an emergency type of situation to get these on the ground. Autonomous robots can play a big job, and they're already doing so in multiple pockets across different countries, doing stuff like sanitization, online medical examination of the people, and when deployed in hospitals, they can definitely help in essentially ensuring that the medical staff can perform their duties without much disruption and keep them as away as possible from possibilities of infection. Another set of stuff is robust diagnostic techniques where AI has helped quite a bit. This basically includes inferring in very fast turnaround time from the X-rays and CT scans of the lungs of the people, voice-based detection of lung disorders, specifically in the case of COVID, where AI techniques can tell with very high accuracy in the high 98% and so forth on whether the person actually is suffering from the infection or not. Another aspect is using IoT plus AI for the pandemic recovery. Here, essentially, the tracking, monitoring, and the delivery functions become enabled and are extremely useful in recovery. Here, drones for surveillance to ensure compliance during quarantine, mask wearing, social distancing with computer vision, they enable essentially to track patients who breach quarantine and ensure that the economy is able to function smoothly without the infection rate increasing or basically becoming reaching a larger proportion. So it also can help in tracing the origin of the outbreak. It is extremely useful for epidemiologists to search the patient zero, to figuring out the persons who got impacted when they came across with the patients. AI can also help in relief to medical staff by remote monitoring of in-home patients, where the huge stress that is placed on the hospital staff can be reduced because AI is helping over there. Going further, biosensors are really capable of providing a sensitive and cost-saving solution, but with high accuracy. Stuff like glucose monitor can help quite a bit in clinical analysis and diagnosis of the disease. In addition, wireless biosensor patches like 1AX and 2A from the Life Signals company are helping out in early detection and monitoring of symptoms of COVID-19 by giving real-time data of temperature, ECG trace, respiratory rates, SpO2, and other measurements, so that at a large scale across a population, a simple patch of the type 1AX or 2A essentially can be put on the chest, and that gives real-time tracking over the mobile phone of the person for himself, and also can relay the data to a central cloud server at the back end, where the doctors can monitor and gives a very good control and monitoring of how the patients are behaving and how the general population is asymptomatic or developing symptoms in such a pandemic situation. In general, going into specific use cases, so AI has a lot of impact in optimizing the sales funnel with the current limitation on the cash flows. AI has a lot of contributions to reducing the cost in a typical sales cycle, which goes all the way from planning for the demand, planning for the marketing budget, analyzing and building the audiences, all the way to detailed targeting, ads personalization, budgeting, bidding in the right platforms, developing a right content strategy, personalizations, recommendations on the website, remarketings, right, and assistance to the customers with voice and text chat, all the way to CLTV prediction, churn predictions, customer feedback, error recognition, and so forth. So in this whole sales cycle, AI has a role to play in all of these steps and make sure it is they are more highly precise. They have better revenue ROI, and they are at a much lesser cost and better automated than in without AI. Another example is in human resources, where in the areas of talent acquisition, training and development, performance management, time attendance, virtual assistants, recommendation engine, and pattern recognition are playing a big role in automating the process, making it more efficient. And at the same time, essentially analytics process powered by trend dashboards, anomaly detection, and predictive analytics are helping out in improving all these processes in the HR perspective. One example is virtual assistant in HR, where a chatbot essentially is able to manage the tickets, HR tickets of the employees of the company in a very effective fashion, without the long wait times or unsatisfactory resolutions or increased anxiety and escalations in the employee population, and making this whole process much more efficient. Another instance is AI in talent acquisition, where the jobs and compensation data from the market is essentially the potential employee kind of candidate data can be aggregated together, and on this NLP based parsing, data cleansing, machine learning based matching, and these algorithms can be run with the appropriate recommendation engines, so that the talent acquisition becomes much more automated, much more efficient and faster. So in healthcare, there are lots of technologies where things are converging together. These include biological sciences, nanotechnology, cognitive sciences, material sciences, and information technology, which are enabling multiple use cases, including gene therapy, drug device combinations, smart materials, minimally invasive surgeries, computer assisted surgery systems, active medical devices, artificial organs, telemedicine, medical imaging, diagnostics, and so forth. And in all of them, AI is already playing a big kind of contributions to improve the automation and efficiency of and the overall impact, and in some cases, totally enabling the use case from ab initio. So one could see essentially the man-machine kind of partnership with AI-powered automation, where AI-powered automation on one hand is enabling medical robotics with surgical robots, rehabilitation robots, smart pills, with various machine learning algorithms across supervised, unsupervised reinforcement learnings, and natural language processing powered by statistical or rule-based NLP, AI voice technology, clinical voice documentation, and voice nursing assistants, leading to improvements in effectiveness, quality, experience and outcomes, safety, ways to ensure patient safety, and efficiency via usability and productivity improvements. So AI-powered automation is essentially leading to improving effectiveness when we have this collaboration of the man and the machine. Here are some specific benefits of AI in the healthcare space. Essentially, AI is assisting physicians in clinical decision-making, replacing human judgment in certain functional areas, example, radiologies, early diagnosis, prediction of outcome of disease as well as treatment, feedback on treatment, essentially to reinforce non-pharmacological management, reduce diagnostic and therapeutic errors, increasing patient safety, huge cost saving associated with the use of AI, and so forth, and including diagnosis of cancers and multiple other use cases. So with deep learning, being able to analyze a huge variety of medical data and using it for very precise outcomes and highly impactful outcomes are all as part of the ML potential impact to healthcare. And this is basically helping in accelerating the process of digesting and interpreting vast quantities of complex and diverse information. One specific example is AI in medical imaging, where AI is being used for efficient image creation, image quality control, workflow optimization, AI-driven detection, classification, and automatic report drafting. In all of these areas, AI is playing a huge role, where huge amounts of data collected and stored is helping multiple use cases through application of AI in medical imaging. In emergency medicine as well, AI can do a lot of contributions and is already being used in the emergency department, kind of revisit prediction within 72 hours, predicting the inpatient mortality of ED sepsis patients, major adverse cardiac events prediction when an emergency case is getting handled, and predicting renal colic in emergency settings. Further, it's helping in patient monitoring, and it's also helping in emergency department operations by forecasting models and simulation tools, giving diagnostic decision tools, which are essential in the ED to screen and stratify patients, building an automated subjective objective assessment plan framework for emergency department reports. In mental health, which is one of the serious problems that has come as a side effect of this particular pandemic, chatbot-based counseling has been proven to be very effective, and it continues to do huge contributions over there in the current scenario as well. So here, essentially using the chatbots which are powered by AI for counseling can essentially help to make sure that people are getting personalized therapy, and it's leading to a very effective improvement of the psychological situations of people who are really in need of them. In electronic health records, use of AI is certainly helping in better clinical decision support by giving diagnostic analytics using medical imaging, predictive analytics using big data, routine integration of medical imaging with other clinical data for triage and critical care monitoring, diagnostic interpretation, treatment modification, and specifically personalized treatment design with precision medicine and behavioral modification. This AI is also leading to smarter search algorithms, and with fully integrated NLP capacity for narrative health data, it is becoming a hallmark of the next gen EHRs. In robotic surgery, AI plays a very big role in the offline and online involvement of the effectiveness of the robotic surgeries. And in classification problems, AI is doing a huge impact to multiple cases in healthcare. This essentially includes diagnostic analysis for the medical imaging, making medical diagnosis based on symptoms, and also designing and selecting treatments based on biomarkers and other attributes. It also is helping in identifying the risk groups based on health-related factors, social determinants, and huge number of multidimensional factors that impact the overall health of the person. One specific case is Aethemia detection, which is using a large data set. This was a study done at Stanford, where if a doctor spends quite a bit of time around looking at a 14-day period of the ECG of a person, it can have an accuracy of roughly around 70-75%, where a neural network or convolutional neural network essentially can be trained to outperform essentially the best of cardiologists and reaching 81% accuracy in detecting arrhythmia. So this essentially has a lot of impact in terms of saving the patient cost of misdiagnosis, saving the doctor time, doing pretty much like a remote health monitoring as a use case over there, obviously lowering the cost and allowing for diagnosis of arrhythmia in very low resource settings where people even may not have access to cardiologists. So IoT essentially is an area which coupled with AI has a lot of impact. Here I show the IoT solutions architecture, where on one hand you have sensors and actuators which are on the field, whether they are wired or wireless. Essentially they give data at a huge scale to internet gateways and data acquisition systems. These systems then relate all the way to what is mentioned as stage 3, which is edge IT analytics and pre-processing, which can provide some decisions right away. And further, they can also kind of collaborate with VMs or servers running in the data center and cloud, where one can do detailed and more heavy lifting of use cases where deeper analytics, AI algorithms need to be run, and corresponding management and archival process needs to be delivered. So AI and IoT has lots of use cases in general. This basically spans from industrial IoT that goes into manufacturing across use cases of predictive maintenance, process optimization, supply chain optimizations, to government where there are smarter lighting, essentially traffic management, citizens tracking, energy grids where you have smart grids and predictive maintenance, retail for automated checkouts, inventory optimization, which is already being heavily used, telecommunications for network maintenance, connected vehicles and homes, and in healthcare diagnosis, early detection and remote monitoring and measurement, to consumer IoT where we have connected vehicles, connected homes, and health and lifestyle use cases, and to science where we have robotics, medicine, and experimental physics. In particular, in the medical space, we have lots of cases where the location and navigation monitoring, the cardiac monitoring, essentially monitoring using ultrasound sensors and other parts of the body, essentially can give huge amounts of data where AI can help to infer the current state of the person. So AI/ML is extremely useful across multiple domains. We have seen many use cases in this presentation, but AI/ML is not an all-purpose solution. One needs to look at and understand the weaknesses of applying AI/ML in particular. So there are cases in which AI/ML would identify superficial features and patterns because it lacks the meanings of concepts and understanding of these concepts. Typically, one ends up understanding the correlations but not the causal relations. So that kind of a domain understanding is extremely helpful and meaningful to get the best impact of using AI technologies. It lacks common sense reasoning and general intelligence, and domain knowledge integration has to be performed explicitly to make sure it has the right impact by enabling the right level of use cases. Typically, it can lack explainability and it could be hard to fix certain identified problems. But now we have a whole field of explainable AI where these things are being explored. A lot of research happening here, a lot of progress already happens, and one could actually explain in certain use cases why AI has taken such a decision and why it makes sense from an intuitive perspective. It needs big data, and machine learning models are pretty much as good as the training data, where explicit need has to be focused on biases, noises, errors, as they often exist in the real world data. And even though we have models which are now, some of the models work with sparsified data, but still a lot of data is needed for many of the use cases. So one has to be very explicitly careful of the type of data and why a model is generating a particular kind of a behavior. It's also difficult to generalize the finding beyond the training data set. This is not easy, and one typically has to resort to innovative techniques like meta learning so that the generalization beyond the current data set can actually be performed by the AI/ML model. So the criteria for the success of AI essentially have to be considered explicitly. So one has to understand what type of particular AI technology can and cannot do. One has to understand the context of its proper use. One has to essentially develop an AI strategy that will bring value to the organization and not being done just for the heck of it or just for the hype of it. And one has to establish performance standards, including objective evaluation criteria, performance measures, pilot implementations, and validations to make sure it has real technical and business impact on the organization, while it ensures the privacy of the data of the customers, the security of the data, and also the ethics when one is building such a variety of AI models in the respective use cases. So an organization, as it develops the capabilities of AI, essentially goes through this advanced analytics maturity path, where initially it starts with descriptive analytics. The data starts coming in, it is cleaned, and the corresponding data is visualized in terms of what is happening, and human reasoning goes into why is it happening. It goes into developing foresights in diagnostic analytics, predictive analytics, where the future gets predicted in the near future, medium-term future, and long-term future across the various features and the nature of kind of elements in the data, all the way to optimizing essentially the aspects about how the business operations can be optimized, how a particular technical operations can be optimized, and then moving into cognitive analytics, where deeper AI algorithms help you in causation modeling using explainable AI and help to really understand the models and try to make them as independent as possible while still working in collaboration with the human decision making. This is where you reach kind of epitome of self-learning and completely automated enterprise, where the corresponding algorithms and models are learning themselves, but then they are working still in the collaboration for overall decision making. And there is kind of the epitome of automation over here. So while implementing AI in the enterprise, one could actually encounter multiple challenges. This could start from stakeholder management, where correct communication and expectation management needs to be set up. The cross collaboration across teams needs to be enabled, whether it is product, tech, business, marketing, and other functions in the organization, because AI/ML would kind of cut across all these aspects to kind of implement a particular project. Hiring of talent and retention of the talent could actually become a crisis given a huge demand and supply gap in the talent over here in this space. AI basically has huge number of continuously evolving techniques and methods across various research organizations, academic institutions, and even corporate research labs. So it can be hard to keep pace with the latest developments in AI. So one needs to be explicitly focused on ensuring that the latest techniques get used. AI performance is probabilistic. It's not necessarily deterministic. Where in typical technology use cases, one has deterministic performance. AI gives probabilistic guarantees, and these guarantees could be as low as 80% or could be as high as 95% or even 98% in certain cases. But in the particular use cases, one has to be very clear on what will be the impact when the algorithm is 80% accurate. Those kinds of cases when it is not accurate have to be appropriately handled. So the experience of the user, the overall performance of the application, the aptness of the use case don't get messed up. Further, one could get into data sparsity issues, availability issues, accuracy issues, where one has to be very careful in the modeling of the algorithms, where corresponding sparsity is considered in the right way. The appropriate techniques are made sure that in the near future, in the medium term or in the long term, appropriate amounts of data becomes available, and the accuracy issues are resolved appropriately with manual tagging, automated tagging, and techniques so that inaccurate data essentially can be reduced. Further, AI can develop bias because of the training data, and this has to be explicitly modeled and considered for the respective use cases. Interpretable AI or explainable AI is an extremely important problem that is being studied, And here, the rationale of the decisions made by AI systems is one of the primary reasons that it is not getting so much automated as it can be. Essentially, using the explainable AI techniques and tools, one can actually understand the rationale for decisions made by these AI systems, by how these models got trained, and how therefore they can be relied upon in making the right decisions when left on their own for certain situations. Self-driving cars are also important on how they would choose between the life of the passenger and the pedestrian, and understanding that if at an intuitive level will help us to make sure that they are independent in making the decisions. In addition, one has to worry about data privacy regulations such as GDPR, and here one has to be very careful that all the particular policies and regulations are followed. So these are challenges of implementation AI in the enterprise, but as we have seen, a lot of companies and startups are moving in this space, so people have found out ways to ensure that these challenges can be overcome. So overall, concluding, AI technologies are essentially advancing at a fast pace, with use cases now impacting, and every industry is essentially using AI to develop a better ROI, to have a disruption in those particular verticals. And AI has a big role to play in the pandemic recovery, whether if we look at from the dimension of economy, from industry, from an enterprise level, from a healthcare perspective, and multiple other perspectives and dimensions. AI actually has already started playing a big role in the pandemic recovery, and we are not kind of falling down to the fears that we have, or the particular impact that the pandemic has to the health of the people. Again, industrial IoT and artificial intelligence with IoT are the backbones of building disruptive organizations and smart factories, and these are also leading to huge kind of economic impact and improvement and enhancement for the respective verticals. Organizations and enterprises therefore need to rise up on the maturity curve of AI so that they don't get disrupted out from their particular domain area, and make sure that they remain viable, meaningful, and are able to adapt in the particular pandemic kind of situations as we see right now. Thank you.
Hi, I'm Vidhya Duthaluru, and today I'll be talking about how we're transforming Uber's customer support and embracing the concept of digital transformation, particularly in light of the new normal that we're all faced with today due to COVID-19. Before we jump in, a little bit about me. So I am a director of engineering at Uber here in Bangalore, and I lead the customer obsession team. The customer obsession team essentially builds platforms that allow for all of Uber's customers to contact us if they have any kind of problem using Uber. So this means riders, drivers, wherever we have eats as a business, our eaters, our courier partners, and so on. And anytime anyone has a problem and they have to contact Uber, they use our systems to be able to contact Uber and get support. I've been with Uber for 2 years. Prior to this, I was leading data sciences and data engineering teams at 247.ai, building predictive experiences. I've also spent many, many years working at Nuance and deploying speech recognition and natural language understanding systems. And that's definitely an area of passion for me. And my interests lie in creating powerful NLP systems that allow us to drive conversational experiences and interfaces with our customers. So let's just jump in and understand a little bit about what we do and what we've been doing over the last several months. As we all know, Uber's mission is to be able to ignite opportunity by setting the world in motion. We have a global footprint. We have our ride-sharing business in several countries. We have the Eats business in several countries. We're often a primary source of livelihood to millions of drivers around the world. And we impact millions of customers' lives, right? It's easy to get a cab when you want to, and it's easy to get an Eats ordered in when you want to. Now, while we don't have the Eats business in India, there are many countries around the world where Eats is a big line of business for us. The interesting thing about Uber is that it is this place where we're obviously using technology to power a lot of this. So technology is powering how we match, when you want to ride, how your ride is matched to a driver who's nearby. It's technology that's powering it. That's the power of our marketplace. But this is operating in a physical world. Now, this is how the world is operating in reality, and you have technology powering it. So we have to use data to be able to power this at scale. Now, the other aspect of this is clearly when you're in a physical world, things can go wrong, right? There are many times when we've all waited in pre-COVID days, we've all gotten a cab, wanted to get a cab, used our app, ordered the cab, but we have an ETA that's supposed to be 20 minutes away, and or 10 minutes away, and guess what? It takes 15 minutes for the cab driver to get there, right? So that's where the physical world is now meeting the digital world, and which means that things can potentially go wrong. There might be defects. The technology may or may not work perfectly. When such a defect occurs, when a customer needs help, is when they contact Uber's customer support. So jumping right into how they would possibly do that. So when an issue occurs, the customer pretty much reaches out through the app or through some other channels and tells us that they have a problem. This could come through the in-app help screen. We have all used that as riders. For drivers, we also have other channels of support. We have the phone channel. We also have in-person support centers where drivers can go to and get help. And we have that, and then we have chat. So you can come in and you can raise an issue to us in any of these channels. And the moment the issue occurs, you raise the issue, the first thing we try and do is understand what that issue might be, and try and see if we could automate it. Automation helps dramatically because it gives you resolution right away, right? If it's a simple issue which can be taken care of, we'd rather do it in an automated fashion because you get instant resolution without having to wait for an agent to come back to you. So if the contact is not automated, then it gets directed to some channel of support, right? And it'll be also routed to the right agent who can get you that piece of support. Now, once the agent gets it, the agent typically looks at the issue, understands what it is, and then resolves that for you and sends you back a message to say that, hey, I've taken care of it. Let's say, you said the fare was higher than expected. We've reviewed it. We were able to refund a part of the fare, or whatever, right? Whatever that issue that you contacted us for. So that's the typical life cycle. Where once the customer writes in, you're able to look at the issue, in some cases automated, otherwise get an agent to resolve it for you within a certain period of time. Now, obviously, COVID threw us several challenges, right? First of all, with the ride-sharing business getting pretty dramatically impacted, with countries locking down quite suddenly in March, there was a significant change in the types of issues that we started to get. Ideally, the type of issues earlier, the type of issues we used to get were more about, let's say there was a challenge, a problem with the trip. Let's say I got charged higher, or my ETA was not what I had expected, or something like that, right? Similarly, as a driver, you might write in and say, hey, I was paid less than I was expecting to get paid, or I had some other problem, with a particular pickup or something like that. So people would write to you about those sort of things, or call you about those sort of things. And it turns out, like, obviously with an impact the ride-sharing business, the types of issues people contacted us for changed. Now there were a lot more COVID-related safety issues. So is it safe to take an Uber cab? Or there were also account-related issues, right? So drivers weren't getting rides. Sometimes they needed to update their documents. Those sort of things started to come in. And this is definitely a shift in terms of the volume, in terms of the actual distribution of contacts that we got. So this meant that less contacts could get automated, because a lot of these required someone to review and make sure we were answering it the right way. Obviously, Uber cares a lot about safety. And so anything that was specifically related to COVID or COVID safety was always treated with utmost urgency. But fundamentally, these were not something that we could automate. Similarly, as the rideshare went down, the Eats business actually saw a big surge. This is because restaurants closed down. to dining options, and they were relying on delivery or takeout. And with cities and countries locking down, the Eats business, where people would order through Uber Eats and get the food home, actually started to pick up significantly. What this meant, again, is that there was a significant surge in the types of issues that people had about, about their order. Just the volumes are much higher right now. So, so we started to see that come in. Now, to compound the problem there, we also saw that with the sudden shift in the lockdown patterns for countries, all channels of support could no longer be available. Getting agents to be supporting things on the phone in a non-office environment was suddenly a challenge, right? Because agents could not come into to the office to be able to handle these issues. Similarly, there was reduced agent capacity, agent staffing due to working from home. And agents were also dealing with new kinds of requests, and they were getting used to working from home. And with all of that, right, obviously there was an impact to the service levels because the staffing wasn't sufficient, the environments had changed. We had to literally shut down some of our agent operations overnight just because these people could not come into work. So we had to arrange for things to be delivered to their homes and so on and so forth. So significant shift in the business, and that too pretty much in like a week or so, which caused a significant strain on the system. Now, what that led to was a serious amount of thought process around how could we really apply digital transformation to the support and to the operations through technology. What are the key things we have to look for? And there are three things I'll talk about today. One is, how do we accelerate automation overall? Like what more can we do on the automation side? How do we look at our in-person support? Remember, I told you drivers can walk into certain in-person support centers. How can we transform that? How can we make it safer for our drivers? And the third thing, in this work from home environment, how can we enhance agent productivity? What are the challenges they face, and what are the levers we have to be able to enhance their productivity? So first, let's talk about automation. So on the automation side, we very quickly have started to work on how do we make help more contextual. So the idea with automation is we can automate it if we can know what you're contacting us about. Now, if it's hard to figure out what you're contacting us about because, let's say, the options are confusing, the help tree is confusing, then it's going to be that much harder to automate, right? Because you may not even pick the right option, and therefore we may not be able to know what your real issue is. So in order to do that, we've actively started to work towards making help a lot more contextual. What this means is that knowing the previous order that you had, and the example here shows an Eats order, knowing the issue that you had, could we very quickly figure out what possibly might have gone wrong, right? Taking an example of an Eats order, let's say the Eats order was dropped off to you in the last 15 minutes. There are possibly a few things that might be wrong with that order, and it's pretty easy to determine that. So can we offer you a more contextual set of options so that the option or the real problem you have pretty much figures in the first 2 or 3, and you're able to quickly take action on that. Similarly, the next thing around the same lines is improving discoverability. Surfacing that information that the user needs much faster, surfacing FAQs a lot faster, and so on. And the third thing is also providing a lot of information upfront. Like, for example, if you have an ongoing order or if you have an ongoing trip, we should present you the status of it. Like, or if you're waiting for a driver and your driver hasn't arrived, we should present you that so that you're not contacting us for things that we have information about already, and an agent is not really needed to give you that information. So those were the 3 things that we aggressively started to work on, because while we had automation flows in place, a lot of the times people were not discovering them. And this started to enable that whole discovery process. So we talked about those 3 things, right? We talked about contextualizing, improving discoverability, and providing instant resolutions. So here are some examples, right? By providing contextual entry points, we can actually engage in a chat-like interaction with you, a chatbot, pretty much, who can have a very conversational interface with you, and you can we can surface options as they come up, right? And it's very logical, as opposed to allowing you to navigate and find this out yourself. It's a very logical sort of step-by-step navigation to allow you to discover automation that already exists, and that instantly gets you that resolution right away, right? That's really the key. If you're able to contact us and we're able to resolve your issue in 30 seconds, nothing like it, then you're done, and you don't have to worry about it anymore. So that has been a big area of focus for us. We've started to actively work on this for our drivers, for our riders, as well as for our eaters and courier partners and so on, for wherever we have the eats business going. And that we've already started to see that this is helping quite a bit, driving more and more automation in support. We've been working pretty hard towards using ML in these areas quite a bit, right? Like, so for example, for the contextual help entry points, we have a lot of trip signals, as I was saying. We have signals around when was your last order, has it been delivered, how often do you order, what's the content of your order, and so on, right? So there are a lot of user-related attributes. There are a lot of order-related attributes, which we can very effectively use to determine what the user might be seeking help for. For example, if you're imagine you are an Eats courier partner who's basically the delivery person for Eats, right? Now, the courier partner may be struggling to find the address. It's easy to know, based on the fact that the courier has actually picked up the order and is very close to the location, that the user might be contacting us because they're either not able to find the address, or they're ringing the doorbell and nobody's answering, and so on, right? So it's easy to surface these things, and just by knowing where in the order it is, and so that's what we've been typically using to try and surface contextual entry points. We have a bot as well to identify the customer intent. We're able to have this conversation, and there too we use natural language understanding models for entity extraction, to understand intents and things like the restaurant name, things like the actual order items, like, hey, I'm missing my Coke from my order, for example. You can figure out that's what's missing and then take action on it. And the third thing, is we're also using other newer BullQ models to actually answer natural sounding questions that people ask, or natural sounding things that people say, right? Like, for example, hey, I've been waiting for my driver and he's not here, or hey, I took this trip and I was dropped off at the wrong place, right? People actually say these things as when they write to us about their issues. And now if you're able to determine what the content of that complaint was, and you're able to determine that this user was dropped off at a place that was not the final destination, you're able to take action on that much quicker, right? You're able to take the right action on that. So overall, this has helped us in truly understanding the user's intent and understanding the reason for the complaint much better. And by doing that, you're able to not just resolve the issue, but you're also able to really circle back, right? Remember, we also talked about making the experience defect-free. Ideally, we don't want these defects. Ideally, we want this to be a seamless experience for each and every person who uses our platform. And by getting these hints from why people are contacting us, you're actually able to drive more and more defect-free experiences, which is really the ideal situation. So that's what we've been doing on the automation side. Now, next, I'll talk about what we've been doing for our in-person support. Right? Like I said, we do have in-person support centers, which have primarily been used by our drivers and our courier partners. And they've been used mostly for things like onboarding, like when a driver wants to sign up to drive for Uber. They're used for things like onboarding, and they're used for things like, updating documents, sometimes for certain support requests that, hey, let's say this is related to when somebody losing an item, or a lost and found item, the driver usually comes to the green light center, deposits the item, and so on and so forth. So they come in for those sorts of issues. Now, obviously with COVID, this needed to change, right? For various reasons, the primary one among them being safety. We needed to make sure that that we know when our drivers are walking in. We also needed to make sure that we could, do the needful to essentially maintain social distancing and all of that. Otherwise, these could be walk-in appointments. We would not know at any point in time how many of these drivers or courier partners we might have, and that would obviously not be good. So there was one of those, that was a primary reason. The other reason is, could we even reduce these? Like, do we even really need these drivers to walk into our centers, right? Could we not solve these by virtual channels? Could we not call them on the phone and resolve their issue rather than having them to make the trip and come in person to resolve it? So this has been a very big area for us over the last couple of months, where we've created a whole appointment system where our earners, or drivers, courier partners, we call them earners, can book an appointment in the app or on the web, and they come in, and when they book that appointment, they not only give us the actual place they want to visit and the date and time, but they also give us the actual issue that they're coming for. So once they give us the issue that they're coming for, you are then very quickly able to figure out, is this issue something that I can resolve just on the phone with maybe a video connection, right? Like, I can still look like it's in-person support by having this video chat with the driver, but you don't have to physically walk into to one of our in-person support centers. So we've been piloting that technology, and it's been working really well. And in fact, drivers are delighted, right? Drivers are delighted that they don't have to make the trip. They're delighted that they're almost getting the in-person look and feel of the whole thing. And we're able to deal with things like things that ideally may be difficult to solve just on the phone. Like, for example, if they want to upload a picture, right, then the agent is able to quickly have them on video, take the picture, upload the picture right away, and that solves their issue very quickly. Similarly, if there are issues around, insurance claims and inspections, the agent is able to have them walk around the car and show things to us and observe that, all being completely virtual. So it's actually pretty phenomenal how we've been able to transform this. And while it's not fully widely deployed yet, it's been piloting in a few places, and it's just everybody's extremely happy with with the results here. So this has definitely been a big area of change for us. And what this allows us to do is really transform support, right? Now, the moment you know that the driver is walking in for an appointment, and you know the reason that they're walking in for that appointment, you're not only able to reach out and solve the issue, but you're also able to do it proactively. Ideally, what we're also doing is looking to see if we can identify when the driver might be having issues, right? It's, for example, let's say a document has expired or there's an issue with the document. We typically know that. And instead of waiting for the driver to come to us and say, hey, I need to re-upload this document, or, I got a notification that my document was not accurate or something. Even before that, we're able to proactively identify it. And we're working on use cases where we're identifying it, and we are reaching out to them and basically giving them, doing this whole video interaction with them and getting that whole thing resolved right away. This is really now where we're able to transform what was an in-person support experience, where somebody had to walk in, come in, wait for an agent, look at their issue, get it resolved, to something where when something's gone wrong, or when your document is not correct, for example, the Uber agent proactively reaches out to you and says, let's solve this right now. Here's where I can send you a video link, and then quickly take a picture of the document that's missing. And with that is quickly able to upload it into the system. So we've probably, reduced the amount of time to resolve that issue from several hours, like including the time you had to drive to go get that support, to being something that was so instantaneous that it's delightful, right? And the driver can just focus on driving and focus on, taking more rides and basically earning money rather than having to deal with all of this. So that's how we've been able to really transform it. And I think this is a big lever for us in terms of digital transformation, because it's changing the way we operate and changing the way we can, and this is something where we can make it better for our earners, even more so than prior to COVID. The other thing that we're focused on, as part of this, is also looking at trying to give, overall sort of differentiated support experiences. Now, remember I told you that we had a challenge with agent staffing. Things are getting back to normal, but back in March and April, there were challenges with agent staffing just because we could not have as many agents available due to various governmental restrictions and so on, right? And so we had to actively work on optimizing our channel mix. What that means is that, let's say phone agents are not available, I'm going to have to deflect some of these to other channels like chat. Similarly, if I have a limited number of phone agents, I want to reserve them for like the extremely urgent, high severity issues that I would like to get addressed right away, and maybe for the rest of the folks, have them work with us on chat. Similarly, using chat support, using a chat bot to be able to, an automation to be able to funnel, to be able to reduce any kind of drop-offs that we have during signups and so on. And the third most important thing is looking at the right channel mix to be able to support our low literacy segments, right? People with, let's say, who are not proficient in tech or not proficient in the language, in certain languages, and they prefer to come to the phone to describe complex issues. They don't want to chat, they don't want to type, typing is tedious. And so we want to try and provide, we have been working really hard to provide asynchronous voice support for them with voice notes, right? So you may not be able to get on the phone and talk to our phone agent, but you can leave a recording, which our phone agent will pick up, understand, and then can leave a recording back for you. And you can listen to that as a driver whenever you get to it, right? This way, it allows the use of voice when chat is difficult. And at the same time, it gives you that feeling of being able to communicate with somebody. But at the same time, even in situations where we don't have phone agents available, we've been able to still support it. So these are all some of the things that we've been doing pretty actively to try and improve our customer experience in spite of the challenging conditions. Next, I'll talk a little bit about agent utilization. So obviously, like I think I mentioned, right, COVID definitely threw us a lot of challenges in this area. We had to shut down some of our agent operations like literally overnight, right? Because the governments decided to lock down and not allow people to move around. And so this definitely posed challenges in terms of making sure that issues that were raised by our customers at that time, would they be even resolved within SLA or not, right? Things were somewhat chaotic. And this is not unique to Uber necessarily, right? I think the whole world was going through that shift. What we realized as part of that, I mean, while we were running a fairly efficient operation, we realized that there were a lot of opportunities to actually make the supply and demand match much more dynamic and much more flexible. Right? We used to forecast most of the times, our actual volumes of agent volumes of issues reaching agents would more or less match the forecast, and we were able to do reasonably well. But when staffing became got to be in very short supply, that became a problem, and we realized SLAs were slipping. And we needed far more supply-demand matching. So we've been actively working at it to try and do that better. Similarly, the other big area for us was just in getting our agents used to working from home. We found that the overall handle time on our customer tickets or customer issues started to take longer due to several reasons, right? Agents were working from home. Sometimes networks were slow. Right, the usual office environment that I was used to, where sometimes you could even go to your, your next door neighbor and ask for a quick tip or something, wasn't there anymore. And we realized that this actually impacted the amount of time agents were taking to handle these issues. And so we started to introduce a lot more automation in it to make it easier. And we also started to, as we investigated, we found that the amount of time the agent takes to understand the issue and do the basic do the digging in to figure out what that is about, that was taking 80% of the time. So now we've been focusing on trying to figure out ways to fix that. So what we've done is we've actually put in enhanced queue analytics where we put in forecasting and monitoring processes to be able to balance supply and demand, right? We use ML algorithms and optimization algorithms for this to ensure that there's a lot closer match between supply and demand. Along with that, putting in a bunch of Q analytics to figure out when there are challenges, right? When are we breaching our SLAs? When is there a spike in contact? When do we have to quickly reallocate people between queues and so on? And then, essentially creating a lot of automated alerts. The moment we have these, when we have these alerts in place, we send it to and these alerts get sent to our workforce management teams. It keeps them informed, right? Like there's a sudden spike in contacts, they're able to quickly jump in and reallocate. Or they're able to at least say that, hey, we will breach SLA for these types of contacts. So overall, just a lot more logging, a lot more monitoring, and ML algorithms to do better forecast and sort of supply demand matching has helped us get back to a lot of the SLAs that we had pre-COVID. And so there's been a lot of innovation in this space as well to ensure that that we've that we're being as efficient. So the positive side of it is, I think we uncovered that there were areas where there were inefficiencies in the past, and all of this push towards getting the right tech in place has helped us become more efficient than we were even before COVID, right? So that's been a big plus point here. The other thing that we've started to look at is enabling, again, right, with COVID, you have agents with potentially spotty availability and maybe, availability, difficulties in certain regions. So one of the things we've started to explore, more work in progress, is language translation. So what sort of language translation services and algorithms can we apply that allow our agents to handle contacts in other markets, right, where we don't have agents there to do it. So how do we do that? Similarly, what sort of agent efficiency improvements we can make in terms of just reducing overall agent, driving a lot of agent-assisted automation within the agent screen itself. So the contact actually comes to the agent, but once it comes to the agent, they have processes that assist them. They have recommendations that are coming to them that allow them to quickly resolve this without even having to do a lot of the investigation themselves. So these are also big areas that we are investing in and proving to be promising. And all of these are going to enable us to try and overcome some of the difficulties that we've been seeing as a result of COVID, to drive more cost efficiencies as well as better customer experiences in the process. So to summarize, what we're going to be focusing on is building systems that provide contextual, personalized, and empathetic responses through automation, right? We believe that these personalized and empathetic responses and contextual responses can actually be provided through automated interactions. Generally, we expect empathy to be expressed in human interactions, but our ML systems are becoming so smart that we can do a lot of this through automation and through ML, and that's what we're going to be focused on. Secondly, I think proactive experiences are way better than reactive ones. So for example, if we know that something might have gone wrong with your trip, let's say your trip took a lot longer than expected, it would be great as a user if Uber reached out to me and said, hey, looks like there was something that went on in this trip, and your ETA was way longer, or the amount of time the ride took was a lot longer. And if Uber reaches out to me and asks me what happened, I think that makes it a really, really good experience. So we're very heavily focused on trying to make a lot more of our experiences proactive. Now, we can't predict every one of them, but we can definitely predict a bunch of them and make that more proactive. Eventually, our goal is to drive as much defect-free experiences as possible, right? We have, with the data, with usage, as people use our services around the world, we have the data to be able to slowly drive towards making these experiences more and more defect-free in the physical world. I think eventually someday, we will be able to make them nearly defect-free. However, the first two, which is providing the personalized and contextual empathetic responses and experiences and making them proactive will take us a long way in improving our customer experience. And that's what we're focused on over the next several months. Thank you.
Thanks a lot, Ankur and Vidhya, for those wonderful insights.